Hello, we are moving on to example 9, which now we're going to move on to graphing exponentials and logarithms. Get excited. Okay, so when we start this, we're going to do this exactly like we did our graphing exponentials in that exponential section that we already covered. Okay, so we're going to start the same exact way, and then we'll talk about how to deal with the logarithm graph. Okay, so we're looking here. Our exponential is f of x equals 2 to the x power. So first we have to ask ourselves, is this a growth or a decay? Which, since the base of our exponential is not a fraction, remember, that means it's a growth. It's going to be growing. So this is a growth. Okay, because your c value is not a fraction. So we know that when we graph this, it should be increasing when we graph our exponential graph. Okay, so our 3 points pertain to our c value. So at -1, remember at -1, 1 over c simply means we find the reciprocal of 2, so secretly like 2 over 1. So that would be 1/2. We flip that. All right, our next point is still 0, 1. That does not change. And then our last point is going to be at 1 and the c value, which the c value is 2. All right, so those are going to be our 3 points. Now, before we graph this thing, we need to know our asymptote equation so we know which line we do not cross. Okay, which remember with our exponential graphs, the asymptote is always on the x-axis, which if you remember, the equation for the x-axis is y equals 0. Okay, so I'm going to go ahead and graph this real quickly. I'll be graphing it in blue since this is all kind of centered around blue stuff. So my first point is at -1/2. All right, my next point is at 0, 1. And my last point is at 1, 2. Okay, and I'm going to draw in that asymptote so I don't forget about it. It's located on my x-axis. So when I draw this blue line cannot cross that horizontal line. So I'm going to get really close to the x-axis, but I won't touch it. And then it'll keep on going up. All right, and then our domain and range. Okay, so let's start with our interval notation. So domain, that's when you ask yourself how far left does the graph go and how far right does the graph go. All right, so domain, you first start by asking yourself, how far left does the graph go? Okay, which if you see here, this arrow means it's headed off to -infinity for forever. And remember, we cannot equal -infinity. So how far left is -infinity? And then you ask yourself, how far right does the graph go? So now we're looking on the right side. Okay, and it doesn't look like it, but I promise you it will continue to get wider and wider. So on this side, all the x's will be used. So from -infinity to +infinity. Okay, which remember, this is interval notation. In inequality notation, since we're using all the x values, that's when we use that funky notation x is all real. All right, so our domain's done. Now for the range, we asked ourselves, how low does the graph go first? Okay, which if you see here, it goes down really close to the x-axis, but it does not touch. And the x-axis is located at 0 on the y. So, since it's located almost at 0 and can't touch, remember we do our parenthesis, because it can equal 0, but it gets really close. And then you ask yourself, how high does the graph go? Okay, or how high does that y-axis go? Okay, so if you see here, this arrow means it keeps going to infinity and beyond with Buzz Lightyear. So it would go to +infinity. All right, and then in inequality notation, okay, we know it involves y because range is y. Okay, and we know it involves 0 of some sort. Okay, and then you ask yourselves, are these numbers larger or smaller than 0? Well, these are larger than 0. Okay, so we're larger than 0. And we can't equal 0 because we cannot touch the x-axis. So that would be my domain and range. All right, so, okay, we kind of talked about this in class, but exponentials and logarithms are inverses of each other. So now you need to think back to the previous section that we talked about on inverses, because this will kind of flow very similarly. So we will go back to this graph, but I'm going to be kind of shifting up right now. All right, so the first thing, we need to find our logarithm equation. Okay, which, to get there, we're going to start with our initial equation, which our initial equation was f of x equals 2 to the x. Okay, which remember, when we do inverses, it's helpful to go ahead and change that to a y. So it just makes life easier. All right, now, the very first thing we do when we convert to an inverse, where we use that fancy word, we interchange our x and our y value. So my x hops over to where y is, and y hops over to where x is. So right now we're just applying our inverse rules, and we're going to be interchanging the x and the y. So we'll get x equals 2 to the y. And then remember, when you solve for the inverse equation, the goal is to get y on one side by itself. Okay, which currently it's trapped in an exponential. Okay, and the only way to get something out of an exponent is to convert that thing to a logarithm. Okay, so when we do this, okay, the base of the exponential becomes the base of the log. Okay, and the log is going to stay on the same side as your exponential. Okay, so it's going to stay with the base. So since the base is on this side, my log's going to stay on this side. It's going to have the same base, which is the 2. And remember, these two trade spots. So my x hops inside the log, and my y hops to the other side. So this would be our inverse equation. Yay! Okay? Now, remember, when we find an inverse set of points, all we do, if you have a set of points, is to interchange the x's and y's. Which I just want to point something out. Okay, all I've done to get these 3 points, I've simply interchanged my exponential standard points. So it went from negative 1, 1 over c, to 1 over c, negative 1. It went from 0, 1 to 1, 0. And it went from 1c to c1. So my x and y just flip-flop, or the fancy word, interchange. So technically, since we already have 3 points, you can just interchange those bad boys and bam, you'll have your logarithm points. So let's start interchanging these things. Okay, my first point was at negative 1, 1/2. So if I interchange those, it will be at 1/2, negative 1. All right, next point, it was 0, 1. But when I flip-flop those points, it will be 1, 0. All right, and then finally, my point was 1, 2. But when I interchange those values, it will be 2, 1. Okay, so I already know what my points will be, which is pretty awesome. Okay, and now we're going to talk about the asymptote equation, which, if you remember, the asymptote equation also interchanges. So it was y equals 0, which was the x-axis, and now it's going to be x equals 0, which is the y-axis, if you didn't know. So not only did my points interchange, now my asymptote is interchanging. So the y becomes an x, or my x becomes a y. Okay, so this time our asymptote is going to be on the y-axis. Okay, so I'm going to go ahead and graph these points. I'm going to start by drawing in my asymptote so I know where the graph can't cross, which this time it will be on my y-axis. Okay, so I'm trying not to touch the y-axis when I draw these points, or drawing my points. So my first point is at 1/2, negative 1, which you just kind of approximate. You go out to the 1/2, or positive 1/2, okay, and then you go down to negative 1. My next point is at 1, 0. All right, and then my final point is at 2, 1. Alright, so remember, we can't cross the y-axis. So I'm going to get really close to the y-axis, but I will not touch. Look at that. Isn't that cool? That's what a logarithm graph looks like. Let's see if I can shift it so you can see it some. See? Isn't that cool? So that's what our logarithm graph looks like. Okay, if you remember, okay, our domain and range also interchange when we have a function and its inverse. So I'm just going to interchange my domain and range. So remember, your domain becomes the range, and your range becomes the domain. So my domain will be the range of the original. So I'm just going to rewrite this step right here in my domain. So my domain will go from 0 to positive infinity. Okay, which interval notation would be, since we're dealing with domain, it's now x. So it'd be x is greater than or equal to 0. Okay? So, and then after that, okay, which let's double check to make sure that makes sense. Okay, so it says my domain goes from 0 to positive infinity. So when we say how far left does it go, it gets really close to 0 on the x because it gets really close to the y, but it can't touch. And then this arrow means it keeps going on for forever. Okay, so it'll keep extending in that direction for forever. So infinity makes sense. Or you could say x is all the values that are larger than 0, which these in fact are, which is pretty awesome. Okay, and then the range will become, or the range will be whatever the domain was of my original. So my domain was from negative infinity to positive infinity, so that's what this one will be. Alright, and then in inequality notation, that would be, this time instead of x, it would be y. So I'm actually going to write those side by side so we're not getting confused. Sorry about that, you guys. Alright, so this will go from negative infinity to positive infinity, and the range will this time be x is greater, or I'm sorry, y is all real. Okay, the domain was x is all real, but now the range will be y is all real. Okay, which let's see if that makes sense. So when we ask yourself, how low does the graph go? The arrow does in fact point down for forever. And then when we ask ourselves, how high does the graph go? Well, that arrow is headed up in a positive direction. So that makes sense. Awesome. All right, so that's our domain and range. And the last step, remember, if these are in fact inverses, they will be symmetrical to the line y equals x. Okay, which if you forgot what those points are, I'll just draw a table real quickly. So we're drawing in the line, all right, we're drawing in the line y equals x. So I'll pick like 3 numbers. So remember, this is the equation or the line where all y values are the same as the x's. So if x is negative 2, guess what? Y is negative 2. If x is 0, guess what? Y is 0. And if x is positive 2, guess what? Y is positive 2. Okay, so that's the graph where all x's equal to y's. So I'm going to draw that in real quickly. So we have a point at negative 2, negative 2. We have a point at 0, 0, and at 2, 2. So let's draw on that line and see what magical things happen. Alright, and if you visualize this, if you had a piece of paper and you folded and creased the paper on that line, I guarantee you that graph would be on top of the other. Isn't that exciting, you guys? Alright, so this is the end of example 9. Example 10 is very similar to example 9, so if you want to try example 10, that will be in the next video, and if you want to try it on your own, go ahead and fast forward to the end when you get done and see if you get it right.